Part 2, Compound Interest. The compound interest formula you learned in previous courses is this. A equals P bracket 1 plus R over N to the NT, where A is the amount of the investment at any time, P is the initial value, often called the principal. Okay, R is the interest rate as a decimal. Now the questions are usually going to be like 12%. Okay, so you would write that as 0.12. Okay, and then the number N is the number of compounds per year, and T, of course, is the number of years. Now, it seems as though we could use this formula and get all the required answers without calculus. In fact, we did use this formula in previous courses and got all the answers we needed. Recall a few sections ago, though, when we were first discussing the value of E. It was stated that E had great importance in compound interest, so here's why. As we increase the number of compounding periods, N gets larger. In previous courses, we used terms like semi-annually, so N was 2, quarterly for N is 4, monthly N was 12, and we even used daily sometimes, and that was N was 365. However, what happens as N gets infinitely large, like compounding every hour, every minute, every second? Okay. Now, the limit as N approaches infinity is called compounding continuously. So let's play with our formula a little bit. Okay, so there's our basic formula. So what we do is let's take, see how it's R over N? So what we do is we make this extra little exponent here, N over R. So N over R to the RT now. See that what happens, or why we would do this, is the R's would cancel. So it's still the same thing. It's still N times T. But we've just done a little bit of rearranging. And now we're going to do a fancy substitution. We're going to make M equals N over R. Okay, well, never going to expect you to do this on your own, but there's some neat things. So if M is N over R, R over N would be 1 over M. So look what happens. You get P, A equals P, 1 plus 1 over M to the M RT. Okay, well, you're probably thinking, why are we doing this? Okay, but the thing is, does the square bracket part look familiar? Well, it should. Okay, because as M approaches infinity, the bracket part, the square bracket part, is the same limit as we discussed in section 1.0, part 2, where we discovered the value of E. So really, this part here, that is just E. So the equation now becomes A equals P E to the RT. Okay, and we use this when we compound an investment continuously. All right, so examples. Okay, a sum of $1,000 is invested at a rate of 12% per year. If only, right? 12% is pretty good. If the value of the investment, or find the value of the investment after 3 years, if the interest is compounded, well, first one is annually. So A equals 1,000. Okay, 1 plus, well, R is 0.12. Okay, we are compounding annually, so dividing by 1 times T. So that's 1 times 3. Okay, and when we type that into our calculators, we end up with $1,404.93. Okay, quarterly, okay, so N equals 4. So A equals 1,000, 1 plus 0.12 over 4 times 4 times 3 years. Okay, when we multiply that, we still end up with 1,400, but this time it's 2576. See, if we compound more often, we get more interest. So that's kind of cool. Daily is 365. 1 plus 0.12 divided by 365 times 365 times 3. Okay, so that works out to $1,433.24. Now, where the calculus part comes in is, what if we compound this continuously? So this is that different formula, P e to the RT. Okay, so we start out with $1,000 e to the 0.12 times 3. That's a 3. Okay, and when we do that, we end up with $1,433.33. All right, so you can see that that is the most interest we're going to get. Okay, 1433.33. We're slightly off from the daily amount, but this represents the maximum interest we could get because that is the most compounding periods. Okay. Number 2. If $5,000 is invested at an interest rate of 10% per year, find the value of the investment after 4 years if the interest is compounded, well, these ways again. So pretty much the same formula. Well, no, it is the same formula. But we're starting with 5,000 this time. 1 plus 0.10. Okay, and the first one is annually, and it's 4 years. So 1 times 4. Okay, that works out to $7,320.50. Okay, quarterly. So 5,000, 1 plus 0.10 divided by 4 to the 4 times 4. Okay, well, this works out to $7,422.53. Okay, daily. So 5,000, 1 plus 0.10 divided by 365 to the 365 times 4. Okay, so that works out to $7,458.71. Okay, and lastly, what if we have a continuous compounding period? So A equals 5,000 e to the 0.10 times 4. Okay, and that works out to $7,459.12. All right, so there you have that one. And last question. How long would it take for an investment to double if the interest rate was 8.5% per year compounded continuously? Okay, in order for the interest rate or the investment to double, how I've taught kids is you just start with any value at all. So let's say we start with $100. Okay, if you start with $100, when it doubles, you end up with $200. Now, if you started with 1,000, you would end up with 2,000. If you started with like $1, you would end up with $2. Doesn't matter what you start with. It matters that it doubles. Okay, so the formula is P e to the RT. Okay, so our amount then would be 200. Our initial part would be 100. E to the 0.085 t's. Okay, first things first, we have to divide by the 100. Now look what happens here. It works out to 2 equals E, 0.085 t's. Why that always works is because we want the investment to double. So even if this was 2,000 and 1,000, this first step would always be 2. Okay, if I wanted my investment to triple, that part would be 3. If I wanted it to tenfold, this part would always work out to 10. Okay, anyways, not a big deal. So we take the ln of both sides. So ln 2 equals, okay, now if I take the ln of that, that exponent is going to jump down. 8/5t's, and then of course ln e is just 1, so we really don't have to worry about that. Okay, and anyways, then we divide by 0.085, 0.085, so t works out to 8.2 years. And there you have it. Thanks, guys. So complete the summative assessments, and when you're done, we'll have the final unit exam for you. Thanks so much. Talk to you later. Call if you need anything.